Hello, everyone. So in this lecture, I will be talking about some application of linear equations. Well, by applications, I will mean like point slope form and how to determine whether two lines are parallel or perpendicular and so on and so forth. So let's dive in. So the point slope form of an equation of a line, or the point slope form of the equation of a line, is given by y minus y1 equals to m times x minus x1. So here m is the slope and x1 comma y1 is the point on the line. So for example, if we have a line and if we know this line passes through the point x1 comma y1, and let's say m is the slope of this line, then the equation of this is given by this formula. Now, how did this happen? Where did this come from? Let's see. Now, in our last lecture, we learned how to find the slope of a function, the slope of a line, and the slope is given by m equals to y2 minus y1 over x2 minus x1, right? So if this is the case, and let's say we have this, I'm gonna change this on the other side. Okay, and here we have the line. It has a slope m, and we know it passed through the point x1 comma y1. Okay, now in order to find the slope of this one, I will need another point, right? Let's call that point x comma y without any index. I will just call them x comma y because this is just arbitrary point. This one is a given point, x1 y1, it's a point, but then I will take another point anywhere on the line and I will call it x comma y. Okay, now let's apply this rule. So I will take this as y2 x2 comma y2, and this one as x1 comma y1. Already it's x1, right? So based on this formula of a slope, the slope of this line will be given by m equals to y minus y1. So instead of y2, I'm writing y, just y, and then instead of x2, I'll write x minus x1. Now, if we solve this, I mean, if we simplify it, then we get m times x minus x1 equals to y times y minus y1. Okay, and if I rewrite this one, we get y minus y1 equals to m times x minus x1, and this is exactly the same with what we have right here. Okay, so this is how we drive it. Now, if we have a point, if we know one point that the line passes through, okay, what we could do is we just substitute the value of y in here, the value of y of that point, and the x value of that point in here, and then the slope value in here, and then we will have an equation. And let's see what I mean by this one. Let's look at this example now. So now we have the formula. So suppose we have now a point. We're given a point. Well, this point lies on the line. So if let's say the line is something like this, if it looks something like this, and then this point is somewhere well, let me say this is 4 comma negative 6, even though it's not the right point. But anyway, we know the line passes through this 4 comma negative 6, okay, and the slope is given by m equals to 3. And now we are asked to write the equation. Okay, So when you have the slope, the information that we need here is we need the slope and we need 1 point, and we have them, right? So if you have the slope and if you have a point, then what you need to use is this formula right here. So I will use that one, y minus y1. But let me rewrite it. First, my x1 comma y1 is the point 4, -6, okay? And my slope is 3. And then I will just plug these values in, and then we have y minus. Now instead of y1 here, I will plug this value, okay? -6. Now remember to put parentheses here because it has a negative, so negative times negative. This you have to multiply this by -6. Equals to m is 3, x minus, and then instead of x1, I will substitute this +4. Okay, and now if we simplify this, so here always when you write equations or functions, whatever, we have to always simplify it to the simplest form. Okay, so this one is y minus 6 plus 6, sorry, times, now we distribute this one, 3x, and this times this, minus 12. And now let's move this one to the other side. If I subtract 6 on both sides, then we have y equals to 3x minus 18. Okay, so here, as you can see, the slope of this one, and this is the intercept. Okay, this is what we call slope intercept form of the equation. Okay, well, we're not asked to write it in slope intercept form, but usually that's the easiest to, I mean, the best way to see the information from the equation. Okay, because once you write it this way, you can easily notice what the slope is, and you can see what the intercept is. Okay, now I can see the line crosses the y-axis at -18. -18, let's say if it is here, the line passes through this one, and then you can figure out what the x-intercept is by just substituting 0 in here, and that's +6. Let's say +6 here, not here, and then the line will look like something like this one. Okay, this is the line. So that's simple. You already have the y-intercept, and you can, by substituting 0 in here, you can find out the x-intercept, and then you can just plot. Because to plot a line or to graph a line, a straight line, if it is a straight line, we just need 2 points. If you have 2 points, then you just connect them because it's straight line. There is no zigzagging, right? There is no curve. So I have 1 point here, this intercept already that we can see from the equation. And the second one, I can find it by just substituting 0 here and solve for x, which is very simple. And that's +6, 6,0, right? And then we have those 2 points and we just connect it. And that will be the graph of the line. And the second question is, well, now instead of a slope, we have 2 points. We know the line passes through these 2 points. That's the information that we have. And the equation, the slope intercept form, no, the point slope form. This is what we call the point slope form, which means we have 1 point and we have 1 slope. Of course, the slope is 1. So the point slope form, we need 1 point and and the slope, right? But here we have 2 points, but no slope. Okay, So what do we do? Because I need this m in order to write the equation. Therefore, well, to find slope, we need 2 points, right? And I can use these 2 points to find the slope first, because we have to find this slope first. So to find this one, you can just start with one of them. Let's say you can take this one as x1, y1, and this one as x2, y2, or the other way, it doesn't matter. Now, here m becomes y2 minus y1 over x2 minus x1. And if you substitute each value in here, we get 3 minus 8 over -7 minus -4. Then we have -5 on top. And here we have -7 plus 4, -3, and that's 5/3. So here we have the slope, okay? And then the next is, well, what is the equation? Because the question is to find the equation of the line, right? Now, we have the slope. This is m, okay? And we have 2 points. And in the first example, we have this slope and there is a point. So we need just 1 point, right? We don't need 2 points. We need 1 point and 1 slope so that we can write the equation of the line. So here, we use both points to find the slope first, and then we use one of them. It doesn't matter which one. We use one of them to write the equation of the line. Just using the point slope form, we take 1 point, one of this, either this one or this one, and then use the slope and write the equation. And let's see if we get the same answer using both points. I will use the first one. So using the first one, we have y minus y1 is 8 equals to slope is 5/3, x minus -4. Simplify this one. 5/3x plus 20/3. And if we simplify this, what do we get? 3y equals to 5x, that's 24 plus 44, I think. Let me see. 3y, this is 24, yeah. Yes. So we have this. And I know this is not the slope-intercept form. You can simplify it, it doesn't matter because I'm just writing this way. And the other one, let me use a different color. I will take the other point now. Here for this one, our x1, x2 is, well, the first point. We use this point, and now here I will use this point. So we have y minus, now my y1 is 3, equals, the slope doesn't change, x minus -7, okay? And here we have y minus 3 equals to 5/3x, that's plus, this is 35/3, okay? And then here, if we simplify this, we get 3y, this is 9 to the other side, 44, yeah. So we have 44. And as you can see, we get the same equations. That means this tells us that you pick just 1 point, whichever is easier for you. Usually you pick the smaller numbers so that it will be easier to simplify it for you. So just pick, first use both of them to find the slope, and then use 1 point and the slope you found to find the equation of the line, okay? All right, and the next is, well, now that we know how to find slope and how to write an equation based on given one slope and a slope and 1 point, or of course, if we have, even if we have 2 points, we can still find the slope and then use one of the points. Now, using the slope, can we determine whether two lines are parallel or perpendicular? The answer is yes. But before we go and try to answer that question or try to explain that question, let's see what the parallel and perpendicular lines are. So two parallel lines or parallel lines are lines on the same plane. It has to be on the same plane, of course, that do not intersect at all. Okay, that means they go parallel forever. So now let's say we have these two lines. Remember the interpretation of a slope. Let's say M1 and M2 are the respective slopes. And at the beginning, when we start explaining about slope, I told you this is somehow the steepness of the line. Okay, how steep this line. So the slope tells us how steep the line is. Now, if two lines are parallel, then does the steepness change? And the answer to this is, well, they are the same. They have the same steepness, that means, okay? Whether one is shorter or taller, it doesn't matter. The steepness is always the same as long as they are parallel. For example, if you take the simple case, if you have two horizontal lines, both of them, they are horizontal, so they are parallel. And if you remember, the slope of a horizontal line is 0. And for this one will be again 0 because the steepness is the same. Both of them, they are horizontal, okay? Therefore, if the two lines, as long as the two lines are non-vertical, okay, we don't want the two lines to be vertical because in vertical case, if the line is vertical, we said M is undefined, okay? A vertical line, the slope of a vertical line is undefined, okay? That's why we need this specification. So as long as the two lines are non-vertical, and if they are parallel lines, then their slope is the same. They have the same slope, okay? So this is very important concept. Of course, it's, if you understand the idea of a slope, then of course, when they are parallel, you expect both of them to have the same steepness, both of them to have the same slope. But now the next question is, how do we use this idea in solving equations or in finding equations of lines? Okay. Now let's look at this again. And perpendicular lines are lines that intersect at a right angle. Okay, they intersect, and the angle that they intersect at is a 90 degree. Okay, 90 degree on four sides, which means right angle. That's what these are what we call perpendicular lines. And here again, we don't want the lines to be vertical. Well, one of them, of course, because if I have a vertical line, the other will be horizontal. For the horizontal line, the slope is 0. But for this one, again, it's undefined. So we cannot multiply or subtract or whatever. We cannot do any mathematical operation in here. Therefore, we don't want this one to be one of them, or let's just generalize. We don't want them to be vertical, okay? Therefore, if they are not vertical, and if we know they are perpendicular, then the relationship between their slopes, let's call this one M1 and this M2, then M1 is -1 over M2, or M2 is -1 over M1. We have this, or equivalently, we can write this relationship, because if you multiply this one both sides by M over 2, then you simplify it and you get this one. So M1 times M2 equals to -1. Okay, so this is the relationship between M1 and M2, or the slope of the first line and the second line. When you multiply both of them, you get -1. So if I give you, for example, the M2, then you can solve or you can find M1 by using this relationship. Or if you know M1, then you can find M2 just by using this relationship. Now, suppose we're asked to find the equation of a line, and this line passes through the point 3, -1. Okay, so the line that we are looking for, or that we are trying to find equation for, passes through the point 3, -1, and it is parallel to the line defined by this equation. Now the question is, what information do we have from this question, or what information do we get from this question? Because ultimately we are asked to find the equation, or to write the equation. So earlier we learned how to write the equation of a line given 1 point and a slope, or given 2 points. We've seen those 2 examples, right? But now what we know is, well, we have 1 point that lie on the line, and we know the line that we are trying to find is parallel to the line defined by this equation. Now, what does this help me? What is this information for me now? Does it help me find the equation of the other line? And the answer is, well, yes. And how? How do we use this equation? First, let's write this one in slope-intercept form. We have 3x plus y equals to 4. Then I can write this. If you move this one to the right side, we get y equals to positive 3x plus 4. Now, what is the slope of this line? So from here, I will call this slope for this one, I will call it M1. This is for this equation, because we have 2 lines now. One is this, and the other is the unknown line, or the unknown equation. So M1 is what? Just this number. So it's positive 4, right? So I know the slope of this line, but, well, this is a different line. What I'm looking for is another line, equation of another line that passes through this point. It's not this line, they are not the same. But what do I know? Well, those 2 lines are parallel. This is very important. So when they are parallel, the 2 lines are, of course, they are not the same, but they have the same slope, which means this M1 that we are saying is a slope of this line is also slope of the other line. Therefore, my M2, or just M, I will call it just M, this is slope for the unknown line, is the same with M1, which is 3, because they are parallel. So I use the information that these 2 lines are parallel to find, or to figure out, the slope of the unknown line. Now, the point slope form, the point slope form is given by y minus y1 equals to mx minus x1. Okay, so if we just use this form, we get, I don't know, okay. Therefore, we have y minus, now my y1 is, here we have the point, which is 3 minus 2. Okay, x1, y1 is 3, -1. Therefore, y minus y1 is -1 equals to m is 3, and x1 is 3, so minus 3. And now we simplify this, 3x minus 9, and then we have y equals to 3x minus 10. And here we have equation of the line. And as you can see, the slope of this line is the same with the slope of, this is the other line, the slope of this line. Of course, there are differences on the y-intercept. That's why those two lines are not the same. Okay, the two lines are not the same, but they have the same slope because they are parallel. And another question is, how about if we have perpendicular lines? Okay, so let's see, x1 comma y1 is 3.6 comma 1.2. So we know the line passed through this one and it's perpendicular to this line. Now what I need is this property or this information that the two lines are perpendicular helps me to find the slope of the unknown line. Therefore, I need to find the slope of this line. So let's call this one M1, okay? And the other one will be M2. Therefore, to find M1, first let's write this one in slope-intercept form. 4x equals to 9 minus y. I will rewrite this one. I will take all this thing on the, or just move y on the other side and this one to the other side. I will just write this one, y equals to negative 4x plus 9. Okay, this is what you get if you simplify. You can follow all the steps. I'm just skipping all, some of them, because this is just operation moving one left to right and so on. So from this, since this is the slope-intercept form, well, M1, you can easily spot what M1 is, and that's negative 4. Therefore, what is M2? M2 is the slope of the unknown line. And what do we know about the relationship between of the slopes of two perpendicular lines? Well, we know M1 times M2 equals to negative 1. This is the relationship between the two lines, the two slopes. So now we know M1, but we don't know M2. We can solve for M2, and M2 is negative 1 over M1. M2 is negative 1 over M1 is negative 4. So we have M2 equals to 1 over 4. Okay, so this is what we have. M2 is 1 over 4. Now we have a point and we have the slope. So the next question is, well, what is, change this one. What is equation of the line? Again, I will use the point slope form. So we have y minus y1 equals to m times x minus x1. So y minus y1 is 3.6 equals to 1 over 4 x minus 1.2. If we simplify this, we get y minus 3.6 equals to 1 over 4x minus 1.2. This is what? 1 over 6 over 5, I guess. I will change this into fraction. Okay, so how do we change this to fractions? This is additional point, additional lesson. So if I have this, because I don't want this fraction, I mean this what you call the decimal, and I wanted to change it to fraction, and instead of having fractions and decimals all same, it would be better to change it to fraction here. So this is 1 and 2 over 10. Okay, 1 full, and these are called mixed fractions. Okay, so this is how we split it. This is tenth, and this is the full before the point. Therefore, you write this one here, and then this is 2 over 10, because we know 2 over 10 is 0.2, right? So basically, this means 1 plus 2 over 10. That's what it means. Okay. So in that case, or you can even do that way. Okay, let me, just to make it easier, I will write it as this is 1 plus 2 over 10. And if you simplify this 2 over 10 means 1 over 5. So that will be 5. 5 plus 1 is 6 over 5. And then 3.6 is 3 plus 6 over 10. And this, if you simplify this one, it will be 3 over 5. And then what do we have? 15 plus 3. This is 18 over 5. Okay. Therefore, I will use this instead of those values. And so we have 18 over 5. And this is 6 over, well, I have to multiply it. So we get 1 over 4 times 6 over 5. Okay, now we need to simplify because we have too many fractions. So this is y minus 5y minus 18 over 5 equals to, this one will be 5x minus, wait, minus 6 over 20. So this will be, if we multiply both sides by the LCM, which is 20, if you multiply both sides by 20, we get here 20y, because this will be simplified, and we get 4 minus 4 times that one is 373, and here we have 5x minus 6. And now we have 20y equals 5x plus 67, right? We have 67, yes. Okay, so yeah, so I don't think we can simplify further. And this is what we have, okay? If you wanted to write it in fraction form, of course you can, to write this one in y to slope-intercept form, then it will be y equals to 1 over 4x plus 67 over 20. And as you can see, the slope is 1 over 4. And that's what we found here, okay? Therefore, this is how we use the information that the 2 lines are perpendicular or the 2 lines are parallel. And another point, maybe you may have questions like this on your homework. If you have, or if you are given 2 lines, let's say 2x plus 4 equals to x. Well, let me say this is, let me put this one is 2y. And then you have another one, which is y plus 2y plus 4x, not 4x, plus x, no. Minus x equals to 10, for example, okay? Now, what can we say about this? If you're given both equations of the equation of two lines, and if you're asked to determine whether these two lines are perpendicular or parallel or neither of them, then what you need to do is figure out what M1 is, figure out what M2 is, then do they satisfy any of the relationship of perpendicular lines or parallel lines? Well, for parallel, we expect both of them to be the same. For perpendicular, when you multiply M1 times M2, you need to get -1. Now, when you multiply them, if you get -1, then they are perpendicular, and if they are equal, then they are parallel. These two lines are parallel. You don't need even to plot to graph the two equations. Okay, so that's the idea, or that's how you can use the properties of slopes of perpendicular and parallel lines. Okay, in this case, for example, here, if you rewrite this one in slope-intercept form, M1 will be half. And again, here, if you write the equation in slope-intercept form, M2 will be half. In this case, since they have the same slope, the two lines are parallel. Okay, and similarly, if you have once you have M1 and M2, if they are not parallel, of course, if this is not true, if they are parallel, then they cannot be perpendicular, of course. But if this doesn't satisfy, if this is not satisfied, you can check this condition, and if when you multiply both of them, if you get -1, then you can say they are perpendicular. Okay. So this is all about for this lecture, and see you in the next lecture.